to solve by factoring, it's a quadratic, which is how we've been factoring. And a quadratic, what does that vocabulary term mean? What is a quadratic? Joseph?
4 terms.
Quadratic, I get it. Quad means 4, right?
No.
But this is not talking about the number of terms. This is talking about the degree. What does the degree of quadratic mean?
2.
Exponent of 2. Good. Which, I get it, doesn't really make sense. What's an exponent of 4 called?
Quartic.
Quartic. Quadratic is an exponent of 2. Right? Math. So we've got quadratics, exponents of 2. It must be in standard form. Which is ax squared plus bx plus c. Does that look familiar? And this is the big part. This is the part that we have never had before. The equation, because it now has an equal sign, it's going to finally have an equal sign so we can find an answer today, must equal 0. All right, so to solve by factoring, what we're doing today, our steps are as follows. 1, write in standard form. It may already be in standard form. And then we skip it. But if it's not in standard form, we need to reorganize it so that it is in standard form. We're going to write it in standard form. We are going to set the equation equal to 0. We're going to factor the quadratic. Now, when you factor a quadratic, there may be a GCF. It may need to be the easy form, x squared plus bx plus c. Or it may be the more difficult ax squared plus bx plus c. There may be a GCF. It may be the easy one, which is just factors of c that have a sum of b. Or it may be the harder one, which is factors of a times c that have a sum of b. So you have to kind of think about which way we're factoring. What's our factoring method? And then this is the new part. So I mean, like, write in standard form, that's new. Or not new, that's old. Setting it to 0 is new. Factoring is old. Here's the next part that's new. You're going to solve for each, or solve for each x. Because when you factor, you usually have 2 factors, correct? You're going to solve for each x. You're going to solve twice. Now I put x in parentheses because it could be the variable r, or it could be the variable t. I think in your homework they're all x's. All right, we're going to do 2 problems. Ready? If I gave you the equation y equals x squared plus 4x minus 21. That is quadratic. Do you agree? Yes, it has an exponent of 2. The largest exponent is 2. So let's go through our steps. Is it in standard form?
Yes.
Yes, it is in standard form. Step 2, set the equation equal to 0. All that means is that instead of y equals, I'm going to change it to 0 equals. So my y value is 0. When I put the answer, because my ordered pair, it's going to be an ordered pair in x comma y, my y value is 0. Step 3, factor the quadratic. Is it a GCF? Is it a quote-unquote easy? Or is it quote-unquote hard?
Quote-unquote easy.
Quote-unquote easy, right? Factors of negative 21 that have a sum of 4. 7 and negative 3. X plus 7 and x minus 3. And then step number 4 is solve each x. We're going to solve it twice. I'm going to take this first factor and solve for x. And I'm going to take this second factor and solve for x. I'm going to show this part with work, just because these are our notes, right? I'm not expecting this amount of work. Because hopefully this is mental math. My first x value is negative 7. And my second x value is positive 3. Both of these solutions make this a true statement. Both of these solutions work in this problem. There are 2 answers to this math problem. The first answer is x equals negative 7. The second answer is 3. My solutions, though, I guess I should put in number 5, are ordered pairs. So I'll add that step 5 up here. Write the ordered pairs. Let's try another one. X squared minus 5x equals 0. Step number 1, write in standard form. Is this in standard form? Yes. Step number 2, set the equation equal to 0. Is it equal to 0?
Yes.
Yes. Step 3, factor the quadratic. There are 3 types of factors. Is it a GCF? Is it easy? Or is it hard? anyway.
GCF, right?
It's a GCF. So what is the GCF? X, which leaves behind x minus 5 equals 0. Step number 4, solve each x. Solve it twice because we have 2 sets of factors, right? So my first one, x equals 0. Oh, that was easy. And my second, x minus 5 equals 0. So then write the ordered pairs. 0, 0. My y value is always 0 because I'm making it equal to 0. And my second ordered pair is 5, 0.
So anything outside of the parentheses is 0. Like an x outside of the parentheses is 0.
Say that again.
Wouldn't what you just explained mean that an x outside of the parentheses or a variable outside of the parentheses be 0?
Yeah, a factor outside of it? Yes, like if you, unless it was, yeah. Yeah. Because even if it was 2x, you'd have 0 divided by 2, which would be 0. All right, we're going to practice a little bit. Are you ready? All right, we're going to start off with a hard one. That's what I want to hear. 20x squared equals 9x plus 18. Woo! That's a big one. What was my first step? What's my first step of my notes? Write it in standard form. Is it in standard form?
No.
It is not in standard form. There are 2 things I could do. What could I do? What could I move? I could move the 20x squared by subtracting it from both sides, correct? Or you could move the 9x and the 18 by subtracting both of them. Doesn't matter. Both will result in the same answer. You just have to do a little bit of this and a little bit of that. Are we good? Minus 20x squared minus 20x squared. So I have 0 equals negative 20x squared plus 9x plus 18. Better? Okay. What else can I do to factor this one? Factor out your negative. So it's going to be 0 equals negative 1, 20x squared minus 9x minus 18. And there's no other GCF, right? Is this an easy or a hard one to continue factoring? This is a hard one. What am I looking for? Factors of... more than that. Negative 360, right? Factors of negative 360 that have a sum of negative 9. They are I will give it to you. Minus 24, that should be a 4, x plus 15x minus 18. 24 and 15. Negative 24 and positive 15. Split it in half. GCF of this half? Yes. 4x, leaving behind 5x minus 6. GCF of this half? 3, leaving behind 5x minus 6. So my factors are 4x plus 3 and 5x minus 6 equals 0 with a negative 1 in front. Did I factor it? This is what we've been practicing, right? The new part is solving. I'm going to take this guy and solve. 4x plus 3 equals 0. I'm going to take this guy and solve. 5x minus 6 equals 0. Minus 3, negative 3, divided by 4. Can I leave it as a fraction? Could you make it a decimal? Are they both the same thing? I'll leave it as a fraction, just because it's a little easier to read. Negative 3/4, comma 0, and 6/5, comma 0. We're going to do one more. Step number 1 is put it in standard form. What can I do the fastest? Subtract the 4. Could you do that mentally and not have to show your work?
Yeah.
You could write 3x squared minus x minus 4 equals 0. What kind of factoring is involved? Is my leading coefficient 1? No. Quota, right, harder. Should we maybe say that? A times C, 3 times negative 4. So I'm looking for factors of negative 12. What times what makes negative 12? But when I add it, I get negative 1. So 3x squared, you said negative 4 and positive 3. Yes? Positive 3x minus 4 equals 0. Split it in half. what's the GCF for the first two terms?
X.
Leaving behind
X plus 1.
x, 3x minus 4. Yes? And over here, their GCF is 1. Leaving behind equals 0, right? So my factors are x plus 1 and 3x minus 4. I'm going to solve both. What's this guy? What does x equal here?
X equals negative 1.
X equals -1. This one, if you need to show +4, +4, 3x equals 4. Divide by 3, divide by 3. X equals, I'm leaving it as a fraction. It doesn't matter. My solution is -1, 0 and 4/3, 0. So we've done an easy, we've done a GCF only, and we've done 2 harder. Remember your steps. Standard form, set it to 0. Factor, solve each factor, write the ordered pairs. The new part, set it equal to 0, solve each factor to get your answer. But it's just factoring.